built a program that uses a convolutional neural network to identify road signs. This is how self-driving cars can begin to understand the signs that they see on the road. When shown this image, the program returns this output, and this prediction is correct. Looking at the dataset labels, we can see that this road sign does indeed belong to class 34, left turn signs. My program has three main parts: processing, a convolutional neural network, and finally a prediction. The images that we see are often unideal for computers to understand, usually because there's a lot of image noise, distracting colors, or the lighting's off. Images are first converted into grayscale, and then they're equalized. Often, pictures will have a small range of whiteness or blackness values, meaning the shades are very close together. When you equalize the images, you take all of the shades and spread them apart. This means that there's a greater range of values, making it easier for the computer to pick up contrast. This is called pre-processing. Here's an image before pre-processing, and here's the image after. A convolutional neural network is an artificial intelligence network that picks out the features of classes, in this case, features of different groups of road signs. It can then use this information to sort new images into the classes. The network uses kernels to look for features within images. The kernel convolves through the image in strides, each time checking for how closely that part of the image matches with the feature the kernel is looking for. Consider this green square an image, and the orange square a kernel. You can see in the red numbers what values, 1 or 0, the kernel is looking for. Pixels on the image that have a 1 in the same place the kernel does gains a match. In this example, the top left, top right, middle, and bottom left pixels all have 1s on both the kernels and the image. That's 4 matches. Therefore, a value of 4 is added onto the feature map. Feature maps are then stacked on top of each other. This process is called pooling. You can add more convolutional or pooling layers to your model. This just allows the program to pick out more high-level features on the images. My model has 2 convolutional layers followed by a pooling layer, and then another 2 convolutional layers and another pooling layer. After being pooled, the image is flattened or strung out. Before, it was 32 by 32, but now it's 1 by 1024 pixels. This goes into the fully connected layers, written as the dense layers in my code. The first layer will have 124 nodes. That's 1 node for every pixel in the image. The second layer has 43 nodes. That's 1 node for each class. Every node in the first layer is connected to every node in the second layer. They work together to predict the class of the image going through them. This part of the program fetches an image from a URL, runs it through the model, and then prints the model's prediction as to what class the image belongs in. This is the image from the URL, and this is the model's prediction. And checking class 23, it is indeed slippery roads, so the model made an accurate prediction.